So here is a Monacor PA948. This is a mono mixing amplifier. It's got outputs for 4 ohm, 50, 70 and 100 volt distribution systems. It's got what have we got here? 4 mic inputs and an aux, and the aux input is actually selectable between line, tuner, CD and tape. Basically it's just 4 RCA connectors. Inside is interesting, to say the least. I've not taken this apart in any way, shape or form yet, but there's some bits in here I'm going to zoom you in a second. Yeah, I'm not sure about, so just bear with me. So to start off with, it's a bit damp. It's been in the outside in the cold, so it's power transformers are big lumps of steel, so yeah, everything else is warmed up and dried out, but they're taking some time to warm up, so they've got condensation on. No big issue. But so it's the main power transformer. This is the output transformer. Now that's a bridge rectifier for the power supply, and that is, it's not a particularly low voltage power supply. So if I get the meter out, as always the leads are all taffled up. It is, if I probe, so yeah, 90 volts, and so it's going to be a plus minus 90 volt supply, which would probably make sense as, yeah, dual 60 volt transformer. So that's the main amp board, is running off a 90 volt supply. But then there's 2 large 22 volt tapping outputs. Well, that's a 22 volt winding on this transformer, which is going into this board down here. Now there's 24 volt DC, so it comes in the back here, follows it round, and it connects to the board just here. There's some posistors and a posistor. Are they posistors? Yeah, posistors. They go, after a certain point, they go real high impedance, limit current, and then there's some diodes to stop backfeeding. But I don't really know what exactly is going on with that. So an amp that runs on dual 90 volt supply rails, is it going to be able to run on 24 volt DC? There's no step up transformer in here at all for the amp. It's not like there's a switch mode power supply. And this small board here has some small TO220 transistors on it, and there's relays and stuff. The mains distribution on this is just weird. It all comes in on red wires only, works its way to a relay here which clicks as soon as you apply power into the amp, regardless of the position of power switch. It's then jumping over to this board here, which is, by the looks of it, a soft start board, some thymistors and a bypass relay. That's going back, in the switch is connecting onto here. So I don't know. Does this somehow connect to the output transformer when the power disconnects? Is this a low power amplifier which disconnects the main amp and connects itself to the transformer just to allow this to function in emergency use? Because the 24 volt DC inputs on these isn't designed for running the amp. It's because they have like alarm settings and announcement settings and stuff on there. They're able to be used as basically emergency announcement system in an evacuation scenario, or you know, is whatever's going on, it allows them to announce it, sound alarms and stuff. So I'm kind of guessing, before I pulled anything apart, that's what that's doing. I could be way off. However, so I do have an issue on this. I don't know if the camera will pick it up. I'll try and put the camera next to the speaker a minute. Don't really know if you can hear that, but it's sort of buzzing and humming quite noticeably. Let me just remount this. So yeah, that, if you could hear it, buzzing and humming, is happening all the time, and it doesn't matter where I'm setting the volume controls and various inputs, it's always there at the same level. So that suggests to me that's on the amplifier end of things. But I know you won't really pick it up on the camera because it's kind of subtle. Well, I wouldn't say it's subtle, but it's not overly prominent in real life. Real life, off camera, to me, to my ears. But everything coming out of it is quite distorted. It's yeah, that classic sounding like someone's singing with a load of food in their mouth, like chewing on a mouthful of gravel kind of distortiony sound. So is that coming from preamp end and getting into the amp, or is that actually at the amp? Is that related to the buzzing? I don't know. I think I might get the oscilloscope out and see if I can see it on the scope. However, I found that in the past to not always work that well. Sometimes it sort of shows itself as a little notch in the output. Other times you can see it as just a strange blip on a FFT sweep. So yeah, I guess that's the next call, is get the scope out, and if I can see it on the scope I can actually probably do some signal tracing with the scope and see if I can figure out where the actual issue is getting injected, but I'm not going to hold my breath on that one. So do you think this might be something to do with it? Watch this. So to start off with, doesn't sound too bad. Sounds like a 1 kHz test tone to me. Nothing particularly nasty sounding, and just somewhere starting to sound a little bit off. Doesn't quite sound right. What am I looking at? And this is only 100 millivolts per division, so the output I'm only getting, if I zoom out, look at the flattening on that, just over 100 millivolts. Look, something very, very wrong there. Very wrong. Let's go higher scale. 500 millivolts per division. Let me turn the... See, look, the bottom part, no issues at all. Going downwards, but the top is just clipping its ass off. Oh yeah. So the question then becomes why? So time to do some signal probing. Yeah, and it seems there's a lot of mains kicking around in this amp. That's going to make things a lot more fun. But let's see if we can pinpoint it down before undoing any screws. Is it just a low power supply rail on some of the op amps on the input? Is it a dodgy op amp somewhere, like the final stage? Is it a solder bridge on a diode? You know, is there a diode in a circuit with a tiny solder bridge on it which is conducting in one direction, or is there something majorly wrong in the amplifier? So a good bit of signal probing, if you can follow the signal, that is, without having to take the thing apart, should hopefully help me pinpoint what area I need to start looking in, instead of just indiscriminately pulling stuff apart and trying to find a fault, because you might get lucky, but it's unlikely. Well, this is just weird. I disconnected the speakers. Well, look, bands have just kicked in. So I disconnected the speakers and I cranked the output up with just the oscilloscope connected, and full signal, absolutely full signal. I thought, okay, it's not doing it under load. I thought, well, first of all, full signal's coming through, so it can't be the preamp circuitry, because regardless of load on the amplifier, the preamp circuitry would have been not affected in the slightest. It would still do it regardless. So I went and got my dummy load out. So if I zoom out from here, you can see there's the dummy load sat there, and now it's not doing it. So I have to reconnect the one thing that was connected before when it was doing it, and that's my loudspeakers. Is it some annoying intermittent fault that's just decided to go, or I don't know? So reconnect the loudspeakers, see what happens. Okay, this is just odd. So each one of these speakers is 8 ohm. I know that's not a real figure. So no speaker connected. I'm on 1 volt per division there. You can see as soon as I connect up even just one speaker, so you can see the distortion there. Yet it's not doing it with my dummy load, even with the dummy load parallel to make 4 ohms. So what's that all about? No other amp does that on these speakers. What is going on? Why doesn't it like these speakers? What's making it do that? Is it oscillating? I couldn't see any. Let me have a look at that a second. So what am I looking at here anyway? What is that? That's so if you do the maths, this is 4 milliseconds per division. So there's 2 divisions. These are about 10 milliseconds apart, these spikes. So if you do the maths, that going to, if one spike 10 milliseconds apart, it was going to be 10 spikes every 100 milliseconds apart, which is 0.1 seconds, which is going to give you 100 hertz, which is an artifact of mains frequency rectification. I'm on 5 millivolts for division, so you know there's some coming through. It's a bit noisier than you'd expect, but yeah. What's this I'm looking at here? What is this? Is it just noise? I mean, I've tried turning all the lights and everything off, and I'm definitely getting that buzzing. So, is this just breakthrough from the power supply? Is it, you know, just bursts of RF from the rectifier diodes and stuff as they're shutting off? It's a bit pronounced to be. Normally you'd see it die off. Why is it? But yeah, but why is it doing that as soon as I connect the loudspeaker to it? What's with that? Yeah, I'm gonna have to like start breaking out some real low impedance loads and see at what point I can get it to do it with a low impedance load. But bearing in mind, at 1 kilohertz when it's doing it such a low level, well, those frequencies exist in real music, so that's why it's sounding so distorted. For some reason, my resistive load didn't seem to bother it, which is just odd. It's got to be able to drive a set of speakers. That's what it's meant to be connected to. Yeah, and I say one speaker's like technically 8 ohm, admittedly a kilohertz. It's driving like the high range drivers. What their impedance is at that frequency, I don't know. But even the valve amp would drive them just happily without that distortion. Little chip amps I've got. Might just try a different set of speakers just out of curiosity, see what happens. Well, if you want just plain confusing, this one's definitely plain confusing now, because if I connect something in series with an 8 ohm speaker, the lowest impedance that can be, no matter how reactive it is 8 ohms, because that's the impedance of the series resistor with it. So I'm going via the output of the amp through an 8 ohm resistor into this loudspeaker, and still, but if I crank it up, it almost looks like it vanishes, but it doesn't really. It's wow, what the hell is going on here? So either I didn't connect my dummy load right last time, which I'm now suspecting it seemed to be connected right, but I did have other wires on the bench. So here it is in series with the speaker, and I thought just in case there's some weird back EMF thing going on, what I've done is connected a jumper across the speaker terminals. So by shorting them out, it's literally then just coming, it's bypassing the speaker. So I get it clipping. bypassed the speaker, now I'm just on my 8 ohm dummy load. I'm still very much doing it. Was I just cranking it up so high before I couldn't notice it? Don't think so. Right, only one thing for it. Completely remove the speaker from the circuit and just make sure I've not... I must have just been doing something wrong. Yeah, there we go. That's very much there. So let me put it into 4 ohms. Let's stop that a second because I don't like it when it goes all haywire. Right. So that's 8 ohms. No doubt about it, that's very distorted. Let's make it 4 ohms. Oh yeah, there we go. Yes, our little feedback this amplifier must use by the amount of signal claps it gets. So let's go down the scale so it's a bit more prominent. Yes, always, as always with the scope, you're just in between where you bloody want it. So, yeah. Right. So, I'll put it back on 8 ohms so I'm not loading it up so much, and then start probing around with my oscilloscope. Oh, yeah, so, well, I think I can already determine, I've already determined really, haven't I? It can't be the preamp section, because if I disconnect this speaker, if I whack this right up, because it will go high, if I disconnect the dummy load, so that's 10 volts per division, I don't think I'm fully disconnected there. I am fully disconnected. So, I could have sworn I was getting more output than that before. Oh, there we are. That's why. So you can see I've driven that into full clipping at that point. Square waving. Can't really see the bottom. I might have to attenuate that down a minute. Let's make that basically 20 volts per division. Oh, behave, scope, behave. Hang on. Did that just stop it? What? What? Is my oscilloscope having an effect on that? That really shouldn't. Yeah, I best just check that, haven't I? Let me load it back up then. So that's clipping. Right, let me put the scope on times 10 mode. And then go down to... Oh, no, look, no, we're still shockingly shit. Just for some reason, my scope seems to be having an effect on it. When it's the only load on it, it must just be presenting enough load. That's the difference between clipping and not clipping when it's totally unloaded. So yeah, like I said, I can literally run it almost flat out before it goes like that when there's no load connected to it. So it's got to be on this amp board. So it's time to pull this amp out. I think that's the next thing to do. So there's 2 potentiometers just there, little blue things just in here. I took note of where they were and tried adjusting them about 3 turns in each direction. No difference to bias at all. Problem still persists. I've put them back to where they are now, but yeah, I'm going to have to pull the amp out. So something's up with it. The joy of analog electronics. This one's worth fixing. This is definitely worth investing a few hours timing, because it's about somewhere around the £1,000 mark to buy this thing new. So it's in pretty good nick. It's in very good nick actually. Bit of spit and polish once it's up and running. If I get it up and running, which I should do hopefully. should be, yeah, looking pretty dapper. So yeah, amplifiers are always fun to fix because you have lots of different components all working as one essentially. You have like different stages within the amp sort of form their own local feedback loops, and then you have a global feedback loop, but you can sort of have feedback between two stages, so you have like a nested feedback loop. All it takes is one component to be out and everything's all just completely way off spec to where it should be. So, and you know, just measuring, saying, well, I've got 3 volts there, and you know, I should only have half a volt across that. So, doesn't mean that part's faulty, because it could be something else completely different, and because everything feeds back into everything else. So, they can be a real pain to troubleshoot, and sometimes you just sort of beat yourself up a bit really when you find something so simple like an open resistor or a tiny cracked joint on the circuit board. And you're like, why don't I just look there first? But that is mostly electronic repair. It isn't the changing the 50p component, it's the finding the fucking 50p component that's faulty in the first place. But so yeah, I think I'll just pull this out quick so I can just have a quick look at it out of the chassis, and then I'm going to call that it for this video because I've been going on long enough. I can't bother to do any more on this tonight anyway. So yeah, let's have a teardown. Everyone loves a teardown. So here she is. It's got 5 output transistors on one side, 5 on the other. Driver, pre-driver and bias circuit. So it is a complete feedback pair. I think people call them like a cycli pair or something. And that's running into an emitter follower. Now, interesting enough on this, I'm going to guess they're tracking the temperature of the output transistors. So because this pairs in a local feedback loop, the temperature of these two here, these drivers for the outputs, if you sort of do that, if you cover that bit up, you've actually got the output stage of sort of a 100 watt complementary feedback pair amplifier. And just like in the amplifier, what determines the bias over temperature drift is actual these transistors here, because these are in a feedback loop, so it's the voltage being generated across these resistors which determines the bias being applied. And so the thermal drift on these transistors is irrelevant. It's only the thermal drift voltage base to emitter on these ones that actually affects the bias over temperature. So you track the temperature of these transistors, not these ones. Now in this circuit, because these emitter followers, and that's where the parallel extra ones go, where those X's are, because the emitter followers aren't actually in this feedback loop, you ideally would track the actual output stage, because there's so much current gain in this circuit. Even under quite heavy loading, you're probably talking just a few milliamps extra current in these transistors. It's not really going to make them get a great deal hotter. And being quite a beefy output stage, you can get away actually with underbiasing these. If these resistors are low enough value, you sort of end up with a bit of a current dumping thing, whereas this section is running as an amplifier, and then as you start loading it up, as the voltage across this resistor increases, these ones then turn on. So you can actually get away just having these biased only just on. So yeah, if you wanted to be really accurate in this stage, you could have 2 bias circuits, one tracking the temperature of these and one tracking the temperature of them, with like 1.2 volts across each one. But it's just not necessary. It's yeah, you just wouldn't do it. It's not necessary. You can underbias this, you can have it biased quite well, and just tracking the output stage will give you sufficient results. It will stop thermal runaway. So yeah, there's a lot on there. It's going to take a while. Lots of surface mount little components. Luckily enough, most of the transistors aren't surface mount, so it makes changing any of them a little bit easier. I like it when you have lots of missing bits as well. You always wonder, was that part of this design that they deemed no longer necessary, or is that for another model of amp? It's kind of like, you can see on the board there's room for additional output transistors, but the heatsink ends but the chassis and everything in the amplifier has the extra room for it. So you kind of wonder, look, this is where the heat sink, so you kind of wonder, did they have it in mind for this design to have these extra ones in, and they've decided to cut down on costs and not put them in, or is that just purely for a different model? But yeah, anyway, it's going to be fun having a probe around on this tomorrow and seeing if I can find the fault. So I hope you found this video interesting to some degree. I see some people watch my videos, which is nice. It's appreciated, whoever you are. But yeah, as always, thanks for watching and catch you next time.